Welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. So now we have to introduce about the CSIR GATE mathematical methods of physics syllabus, right? Already I told you I will upload after some time which course we have to start from January 2024 onwards. We started the Quantum Online Academy in online mode only. So please listen my course and subscribe my channel. Okay, right? Subscribe my channel and learn the physics subject. You enjoy with the physics subject. So what is the CSIR and GATE examination? Whoever completed the MSc in physics are allied subjects interdisciplinary to the physics subjects. Suppose astrophysics, astronomy, other people, some space physics like that people also can apply the CSIR physical science and GATE PH physics subject, right? Once you have to see, CSIR is a body, that is the Council of Scientific Industrial Research Body. GATE exam will conduct every 1 year, one IIT will conduct. CSIR exam, the previously CSIR body only conducted. Now onwards, 2019 onwards, 2018 after some time, 18 onwards, NTA people, National Testing Agency people are conducting the CSIR examination. Here in CSIR GATE, whatever it may be, total 9 papers we have. How many papers? 9 papers after completion of the MSc Physics. So what are the papers are there? Total 9 papers are there. One paper I will give the introduction and then I will upload in your my YouTube channel. You have to subscribe my YouTube channel and you share to your friends. Clear? This is more informative video. In this video, what are there? First, syllabus is there. The second, what are the reference books are there, the strategy of the exam is there, and last, how the question paper pattern is there, how questions are coming, those things we have to discuss in this video. So this video is very useful to you. Once you have to like my YouTube channel and share to your friends. Clear? So once we have to go for this. Mathematical methods of physics, syllabus, paper pattern, solution of the old questions we are explaining in this video. Now we have to see. So what is the syllabus is there? In CSIR, 2 parts of the syllabus is there. In mathematical methods of physics only, 2 parts is there. One is part A, another one is part B. So what is part A? Part A is a core syllabus. Which syllabus it is? Part A is a core, right? Part A, if you have to take the part A is a core syllabus, core. So in core syllabus, what are the topics are there once you have to see? Dimensional analysis. After some time I segregated these topics. Now you listen, right? First topic is dimensional analysis. The second one is vector algebra and vector calculus. The third one is linear algebra. Within the linear algebra only, matrices, Cayley-Hamilton theorem, eigenvalues and eigenvectors up to here. So up to here linear algebra only. Next later, linear ordinary differential equations of first order and second order. Linear ordinary differential equations of first order and second order. Some special functions are there. Those special functions are Hermite polynomial, Bessel polynomial, Laguerre polynomial, Legendre polynomial. Laguerre polynomial and Legendre polynomial. Suppose you have to take Hermite polynomial, you have to write Hn of x. Bessel polynomial, you have to write in Jn of x. Laguerre polynomial, you have to write Ln of x. Legendre polynomial, you have to represent as a Pn of x, right? So these are the polynomials, very important. Up to here eigenvalues, ordinary differential equation, this polynomial also within the differential equation only, right? Now you see Fourier series, subsequent Fourier analysis and Fourier transforms, Laplace transforms are there. This is one part. Now you have to take elements of complex analysis, analytical functions, Taylor's and Laurent series, poles, residues, evaluation of integrals, elementary probability theory. This is the complex analysis part, right? Now elementary probability theory, random variables, binomial, Poisson and normal distribution, central limit theorem. This is the syllabus. So in part A, majorly how many parts are there? Dimension analysis 1, vector algebra 2, linear algebra 3, differential equations 4, Fourier series, Fourier transform and Laplace transform 5, a complex analysis 6, and probability theory 7. Total 7 number of topics are there, right? Now part B. Part B is a advanced part. Maybe which purpose they are conducting the CSIR exam? To make them experts in physics. Otherwise you may become as a physics professor, or you may become as a scientist, you may going into the research oriented. That's why what are the challenges are coming in the world, what are the challenges are facing. So those challenges scientists are demolishes. They are finding the solutions for getting the challenges in the world, correct? So for that, some advanced part also they are taking. This advanced part, what it will give? It will give the research oriented topics, right? So these syllabus maybe you have read in your MSc, you not read in your MSc, but even though CSIR people kept in their syllabus, clear? Now you have to see what is this? This part B is a advanced part. Which part it is? No, advanced part. In advanced part, Green's function, this is also differential equation, the part of the differential equation, partial differential equation, their Laplace equations, wave equations, heat equations in 2-dimensional and 3-dimensional. This is one part. This is under differential equation only it will come, right? Next, elements of computational technique. This is the new topic, new version, that is a 7 now. Now you have to take this one is a 8. Elements of computational techniques, roots of function, interpolation, extrapolation, integration by trapezoidal rule, Simpson's rules, Simpson 1/3, Simpson 3/8, solution of first order differential equations, Runge Kutta second order, fourth order, like that, Runge Kutta methods, finite difference method. Up to here, finite difference method, under it will come the probability theory only. So next, tensors. This is another topic, tensor. Now you have to take group, special theory groups are there. Introductory group theory, that is a SU means special unitary group. Special unitary group. SO means it is a special orthogonal group. Special orthogonal group, right? These type of groups are there. This is also very, very important. What are the questions are coming? Those questions we will discuss now. This is the syllabus for CSIR. Already initially I told CSIR people 2 ways is there. One is the part A, one more is part B. In part A, once again you have to see 7 components are there. In part B, 8, 9, 10. So this one is coming under the Green's function partial differential equation. I kept under differential equation only. Now I segregate how the pattern, exam pattern, how it will be. Exam pattern, how it will be, exam pattern for a CSIR examination. Already I told in CSIR notification, we uploaded in YouTube also. That time I shown this one. Now you have to see. Total number of questions, you will get the 75 questions you have to get, total number of questions. Within the 75 questions, 20 questions for part A. So part A is, it shall be common to all subjects. This part shall contain questions pertaining to the general aptitude. Which one it is, Nana? General aptitude with emphasis on logical reasoning. It must be logical reasoning, graphical analysis, analytical and numerical ability, quantitative comparison, series formation and puzzles. So like that is there. This is completely general aptitude. The general aptitude, within the general aptitude, you have to prepare for this content. Logical reasoning, one question it will get. Graphical analysis, one question you have to get. Analytical and numerical ability, 2-3 questions you will get. Quantitative comparison, 2-3 questions you may get. Series formation, puzzles. These questions you may get for 20 questions. Out of 20 questions, how many questions you have to attempt? 15 questions you may attempt. What is the each question shall carry the marks 2 marks? It is a 1/4 negative. That is a each question, each wrong question you may lose 0.5 marks. Now part B. This part B is physics. So this physics, some basic ideas, basic concept. Part 1, other part 2 also sometimes they may ask. Basic ideas. What is the basic idea? Those questions you may get from part B. How many questions? 25 questions. How many questions you have to attempt? 20 questions. How many marks for each question? 3.5 marks, right? 3.5 marks. Each negative, this is also 1/4, 0.875 you may lose. For physics, 3.5 questions are there. 3.5 marks questions are there. Very, very important. So please remember, 3.5 marks questions are there. Now part C, this is very, very important. If you may not get these two also, if you have to do this part, you will get the CSIR clear, right? Now 30 questions you may get. You may attempt 20 questions. Out of 20 questions, each and every question carry 5 marks. Each and every wrong question you may lose 1.25 marks, right? Total 200 questions. Total physics questions you have to take, total questions you have to attempt 55 questions. Out of 200 questions, you may, out of 200 marks, if you get the 100 marks, you may become first rank, right? This is very, very important. This is the pattern, CSIR examination pattern. Please remember, here 3 parts are there. Within the 3 parts, part A consists of the general aptitude, part B is physics, part C also physics, but this physics from advanced part. Advanced or logical reasoning, research oriented topics they will ask, right? For each question, 5 marks you may get. If you have to attempt the 20 questions correctly, you will get the 100 marks. You may clear the CSIR examination. Only 20 questions if you have to do, you may clear the CSIR examination. That much of strength is there, right? Not, CSIR is not hard. If you have to write your area, whatever the area you studied, from that area questions may get in your CSIR exam. You never miss that question. You never miss that area. Then easy to you crack the CSIR examination. That is the procedure of the CSIR exam. This is the, which one it is? CSIR examination pattern. Now GATE, graduate aptitude test. This is also very, very important. Whoever clear the GATE examination, they may go to the NITs, they may go to the IITs doing for MTech. Otherwise, they may join in PSU, public sector undertaking companies are there, no? So these companies not conducting the exam. Now they are taking the candidates from whoever got the more score in GATE examination. They are calling based on the GATE rank score, right? So they are taking the interview and they are giving the job directly also. Otherwise, if you want to study, so you have to study MTech with PhD through GATE. In NITs, IITs or central universities also, you may approach, guide and you may join through the notification. This is one more subsequent way, right? After you may not get the CSIR, through GATE also you have to enter. One more way is there. Now you have to see what is the syllabus is there. Compared to the CSIR syllabus, GATE syllabus is very less. Topics also small topics are there, right? Now you have to see. Vector calculus is there. In vector calculus, there also is there. But here some different topics are there. Linear vector space, basis, orthogonality and completeness. So this belongs to vector calculus. Next, this one is one topic. Next, matrices. This is a linear algebra. Similarity transformations, diagonalization, eigenvalues and eigenvectors. This is the second part of linear algebra. This is linear algebra compared to the CSIR syllabus. Next, third one you have to see. Linear differential equations. Second order linear differential equations and their solutions involving the special functions. That one you have to take special functions. Now you learn in CSIR, whatever the Bessel, Legendre, Hermite, Laguerre polynomial is there, no? Those polynomials you have to see here. Now the fourth one, complex analysis. In complex analysis, Cauchy-Riemann condition, Cauchy's theorem, singularities, residue theorem, applications. This is the fourth one. Now fifth one you have to see Laplace transform, Fourier analysis. There also Laplace transform and Fourier transform and Fourier series is there. The sixth one, elementary ideas about the tensors, covariant, contravariant tensors. Only 6 topics are there. Here numerical techniques are not there. Here special unitary functions are not there, right? Here which one is not there, Nana? So whatever the syllabus, partial differential equations, green functions are there, no? So those things are not there in GATE section. It is a section 1. Now you have to see what is the exam pattern of the GATE. GATE also 2 types of pattern is there. One is general aptitude questions. Total 2 parts is there. One is general aptitude. 15 questions you may get. From the 15 questions, question number 1 to 5, you will get the 1 mark question. This is 1 mark question. Question number 1 to 5, each question you get 1 mark. Question number 6 to 10, you may get 2 marks question. 2 marks. Question number 6 to 10, 2 marks. Question number 1 to 6, how many marks you get? 1 mark only you have to get. This is the general aptitude. How many questions total? 15 questions you will be able to get in GATE examination. Now physics. Physics total 85 questions. 85 questions you get. 85 marks. This is 85 marks, not questions. 85 marks. This 15 marks. You may get the maximum. This one is 18 marks. Right? Now you have to see. 11 to 35, question number 11 to 35, you are getting the marks 1 mark. Each question 1 mark. 36 to 65. 36 to 65, you are getting how many marks? 2 marks. Each question you have to get the 2 marks. Within the 11 to 65, 65 minus 10. How many? 55. So 10 questions from general aptitude, 55 questions from physics. 10 questions from general aptitude, 55 questions from physics, right? Total 100 marks is there. Within the 100 marks, you may get 2 marks questions are there. You may get 1 mark question also is there, right? In general aptitude also. Here, so in 2 marks question, in physics, there is a 3 orientation of questions are there, not multiple choice questions. All are not multiple choice questions. questions are three orientations are there in physics only. One is multiple choice question, MCQ. MCQ matlab multiple choice question. If it is MCQ, multiple choice. Next, multiple selected questions. Multiple selected questions. You have to take a multiple selected questions means one question they will give. They will ask multiple options correctly. You have to select A is correct, B is correct, C also will correct, D also will correct sometimes. A, B, C, D, E correct. Like that you have to select the options, right? This is purely computer based examination. Within the computer, you have to take the mouse and you have to select the, which one you have to select, whatever the correct option. A option, if you have to get the correct option, A option you have to select. B also correct, B also you have to select for same number. That is a multiple selected question. Next, numerical answer type question. There is no option. Answer they will give. Answer they won't give. You have to enter numerical answer type questions. NAT. Numerical answer type question. This is very, very important. Numerical answer type you have to enter. For numerical answer type questions, no negative. Please remember, no negative. Only for numerical answer type question. Rest of the question there is a negative is there. So for you have to take multiple choice question, you get the negative mark, and multiple selected question, you get the negative mark. Only numerical answer type question, no negative mark is there. This is the GATE exam pattern. Now, what are the reference books? Which books you have to refer? This is a PG level subject. So that's why you have to read more books. Whatever the books in 10th class, in intermediate, in degree, you may get notes or you may get some one book. It will give the more information to you or sufficient information to you. But in PG, we are not taking the one book. One book won't give the sufficient material, won't cover all the subjects. So that's why we have to follow many books. Suppose I gave 6 books I gave once, you have to see. Mathematical Methods of Physics, H.K. Das, B.D. Gupta also is there, B.D. Gupta, H.K. Das, B.D. Gupta, maybe Andhra Pradesh and Telangana people are following Satya Prakash also, Satya Prakash, that one also you have to follow, no problem. So whatever it may be, these are the MSc level books, Mathematical Physics, H.K. Das, B.D. Gupta, Satya Prakash. Next, Higher Engineering Mathematics. Higher Engineering Mathematics, B.S. Grewal. This book is very, very good book, right? Next, third one you have to see, Advanced Engineering Mathematics, Irwin Kresick. This book is very nice. Advanced Engineering Mathematics book. Next, Complex Variables, Scam Series, Murray and R. Spiegel. This publication is a Tata McGraw publication. Nowadays, these people are not publishing these scam series. These are old version books. Very, very nice. Solutions are very, very nice. You may get in your old library. Complex Analysis, Scam Series, Murray or Spiegel. Next, Vector and Tensor Analysis with Application, AI Borisenko and I. Tarapo. These vector and tensor analysis. For tensor purpose, you have to follow this one. Next, Mathematical Methods in the Physical Science, Mary L. Boas. Mary L. Boas, this book also nice book, Mathematical Methods in Physical Sciences. Within these books, any one book you have to buy, no problem. All the content is there. For topic wise, these scam series books are very, very important and nice books. You have to follow these books also. Take the problems and solve the problems. May you get in examination. Next, I am segregating. Entire the syllabus I am segregating. How many parts I have to segregate? Total 10 parts I am segregated. Suppose if you have to see the entire syllabus, book size is this much of volume is there, you unable to read the entire portion. You are afraid. So that's why I am segregating into the 10 parts. If you have to participate, you have to make a parts in that book, it is easy to read and to revise, to memorize and to remember the things. It's very easy. That's why first you have to take. First part I segregated dimensional analysis. Dimensional analysis. You may get 3.5 question, 3.5 marks question from CSIR or 1 mark question from GATE. So dimensional analysis, units and dimensions, what are the one question I gave, you may get the idea. Now the second one you have to see vector algebra and vector calculus. In vector algebra, vector calculus, you may get 3.5 in CSIR and 3 marks in GATE. In CSIR from mathematical methods, in CSIR examination, from mathematical methods of physics, how many marks you have to get? Around 35 to 45. 35 to 45. 35 to 45 marks you may get from mathematical methods of physics based on the paper setter, right? Sometimes you may get 35, sometimes you may get 45 also. That much of weightage is there, right? If you have to take the GATE, 18 marks. Out of 85 marks, you may get the 18 marks. This is also very, very important topic for GATE examination also, mathematical methods of physics. If you are an expert in maths, every physics subject is easy. Whatever the classical mechanics, quantum mechanics, solid state physics, mathematical, electromagnetic theory, electronics, rest of the papers are there, no? Those papers are very easy if you have to sound in mathematical methods of physics, right? If you have to sound in mathematics of physics, rest of the papers are very easy. Next, now you have to see linear algebra, matrices, Cayley-Hamilton theorem, eigenvalue, eigenvectors are there in this. In linear algebra, you may get 10 marks. In CSIR, 3 marks for GATE. In a linear differential equation, first order, second order, including with the special functions also, including with the special functions and Green's theory, right? Partial differential equation, partial differential equation, all the things you have to take in one. In advanced part also you have to take. You may get 13.5. Here 2 5 marks questions, 1 3.5 marks question you may get. This is very, very important topic, linear differential equation. Linear differential equation is a very, very important topic. You may not lose this one, right? 3 for GATE. Fourier series and Fourier transform and Laplace transform. This is also important. You may get sometimes 5 marks question or 3.5 mark question, whatever it may be. In GATE examination also you may get these questions. Next, elements of complex analysis. This is very, very important for CSIR or GATE. 2 long questions, 5 marks questions, 2 you have to get. That is the 10 marks. Plus 1 3.5 marks. So sometimes 4 also you may get. So 13.5 majority you may get. Complex analysis, the singularities, Laurent series, Taylor series, Cauchy residues theorem, you have to find the residue or integrals, whatever it may be, they may ask. 3 marks you may get in GATE examination, whether it may be 2 marks question or 1 mark question you have. From probability theory, you must get 1 question from 5 marks, that is a probability theory. 3 marks from GATE. Elements of computational techniques. Here numerical analysis it is. Maybe in your degree you may learn, some people are learning the complex analysis, some people are learning the numerical technology based on your college teacher. But here numerical technology is there, interpolation, extrapolation, trapezoidal rule, Runge Kutta rule, finite difference method, central limit theorem, all the things come under the numerical technology only. Elements of computational techniques only we will get it. So this one is 5 marks CSIR, one pakka question will come, that question is long question only 5 marks, but it is not there in GATE, 0. For GATE it is a 0, not there in GATE, only CSIR syllabus. This one is only CSIR, right? Next, tensors, in GATE also is there, 2 marks in GATE, 5 marks in CSIR it will come. Introductory group theory, 0 marks in GATE and 3.5 marks in CSIR. Now you have to see, entire the syllabus if you have to take, it will appear as a big. If you segregate dimensional analysis, within 1 hour you have to revise. Dimensional analysis, what is the unit, what is the dimension, you have brief ideas, so then you are able to do that one. Linear vector algebra and vector calculus in 3 integrations and 3 differential forms are there, and vector algebra, cross product, dot product, and normal planes, all those things we have to learn from that. Within the 1 day, at least 1 day, maximum 1 day. Next, linear algebra, within 1 day we have to read. Linear differential equation, maybe 5-6 days it will take. Fourier series, Fourier and Laplace transform, it will take 5-6 days. Elements of the complex analysis also it will take 5-6 days. Elementary probability theory it will take 2-3 days. Elements of computational techniques maybe 1 day we will finish. Tensors we will 1 day, and introductory group theory also we have may finish 1 day, right? Maybe at least 1 month you have to keep. For mathematical methods of physics, you keep for 1 month. Within 1 month you have to segregate like that, you may prepare your examination, right? You may crack entire the examination. It is very easy, like this you have to segregate. Clear? Now, how questions came in your competitive examination, you have to see. This question was December 2015. When this question came? December 2015, this question they are asking. In the scattering of some elementary particles, the scattering cross section is sigma. What is they are asking? Some elementary particle is scattering. The scattering cross section, which one it is, Nana? Sigma. The scattering cross section is sigma, is found to depend on the total energy. What is E? E is the energy. E is the energy, right? Next, and fundamental constant H. H is a Planck constant. Fundamental constant, that one is the Planck constant. H is the Planck constant, right? And C is the speed in the light in vacuum. C is a light speed. Where it is light speed? In vacuum, the light speed. What they are asking? Using the dimension analysis. Already I told, this question belongs to whom? This question belongs to dimensional analysis. Dimensional analysis. This question belongs to dimensional analysis. Please remember the first topic. Each and every topic, one question I am explaining. Okay. So now you have to see dimensional analysis. The dependence of sigma, scattering cross section, on these quantities is given by option A, option B, option C. Option A, option B, option C low. So in option B, A, option B, option C, what is the unit of sigma? What is the unit of sigma? It is equal to area. Area is equal to meter square. So one born, or how many meter square? Meter square or born? You have to take the born also. One born is equal to 10 to the power of minus 28 meter square is there. This is the unit of the scattering cross section. Now you have to check it. Options you have to check. First you have to take this one. What is the unit of energy? The unit of energy is equal to joule. What is the unit of the Planck constant? The Planck constant unit is equal to joule second. What is the unit of velocity of the light? velocity of the light unit is equal to meter per second. Now you have to calculate. How you have to calculate? Once you have to see. I am taking the option A. What is that one? Option A I am taking. What is option A? Square root of hc by E is there. Now you have to take. What is the unit of H? You substituted here. Joule second. Unit of H is joule second. What is the unit of C? Meter per second. What is the unit of energy? Joule. Joule get cancelled. Second get cancelled, right? The rest of the thing you have to write root m is there. But what is our cross-sectional area unit? Meter square. But option A is wrong. This is root m we are getting. Next, second one you have to see. What is B? You have to take the B. H is equal to hc by e to the power of 3 by 2. What is H nana? Joule second. What is C? Meter per second. Right. What is E? Joule to the power of 3 by 2. Second we have to get cancelled. Here joule to the power of 3 by 2, joule to the power of 3 by 2, joule to the power of 1 is there. Joule to the power of minus 3 by 2 plus 1 into meter. Right. Joule to the power of minus 3 by 2 plus 1 is equal to how much? Joule to the power of minus 1 by 2 into m. So this one, so this is also not correct. Correct? So this is a meter by root j. This is not correct. Now I am taking for this one. What is the option C? Option C, hc by E whole square. What is H? H is a joule second. What is C? What is C? C is a meter per second. What is E? Joule. Joule. Second get cancelled. Whole square is there. This is equal to meter square. Which one is correct? C is correct according to this option. So now like this you have to do. What is the option 1 correct? hc by E whole square is correct. According to this problem, option C is correct. Like that you have to see. Option C is correct for scattering cross-section unit. Right? Like this we have to do. Which area this is? From the dimensional analysis we got. For how many marks? For 3.5 marks. If you have to do this one, you get the 3.5 marks. When we got? December 2015 CSIR people are asking this question. Right? It is very easy. Now the next one more question we have to see. Right? This is second. Total I segregated the 10 parts. From each and every part, one question I am explaining. Not all the questions I won't explain. If you have to like my lecture, you take my app, that is a Quantum Online Academy app. Go to the Google Play Store and take my app. From that app, you purchase the course, CSIR course, and then you listen my classes, right? Maybe next month, 7th onwards, we have to start this course. Let R denote the position vector of any point in 3-dimensional space. R is equal to the magnitude of R. Then what we have to do? Right? First, R is a position vector. R is the position vector. X into I cap plus Y into J cap plus Z into K cap. This is the position vector. The magnitude of R is equal to square root of x square plus y square plus z square. Then you have to take here. Del dot R is equal to how much they are asking. First, you have to find del dot R. Del dot R is equal to, what is the del nana? I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot, what is the R? R is equal to x into I cap plus y into j cap plus z into k cap. Now you have to do the dot product. Dou x by dou x, dou y by dou y, dou z by dou z. I dot I is equal to 1, I dot j is equal to 0, I dot z is k is equal to 0. So therefore, dou x by dou x is equal to 1, 1 plus 1 is equal to how much you have to get, Nana? Del dot r is equal to 3. Similarly, del cross r is equal to how much? Del cross r is equal to, how we have to do, Nana? I, j, k, dou by dou x, dou by dou y, dou by dou z. R is equal to x, y, z. Now you have to find the cross product. I into those, which one you have to write? Dou y by dou x. Dou y by dou x minus dou x by dou y. So dou y by dou x is equal to 0, dou x by dou y is equal to 0. I into 0 minus j into 0 plus k into 0, right? So therefore 0 in z is equal to 0. What is the option correct? Now you have to take a D option. Option del dot r is equal to 3, del cross r is equal to 0. This question came in which year? December 2014. CSIR people are asking this question, right? For 3.5 marks. 3.5 marks. Everyone can do this question. If you have to idea, del is one operator. That operator you have to operate with position vector. Easily you may get this option, right? Option D is correct. Which one is correct? Option D. This is the second one. From which area we got? Vector analysis. Vector analysis. This is the second area. From vector analysis, questions may get like this. Sometimes you may get easy, sometimes you may get tough question also. That is also easy only if you have to read. Next, third one. Third, I segregated 10 parts now. Each and every part I am giving. Third one, which one it is? One's linear algebra. Third one is a linear algebra. This linear algebra is matrices is there. In the linear algebra, which one is there? Matrices. These are very, very important. Topic is very, very important. Which of the following cannot, please see, cannot be an eigenvalues of a real matrix. Eigenvalues of a real matrix. Suppose one matrix, suppose any matrix, one statement I will give. From that statement you have to see the options. Any real matrix, suppose if A is a real matrix. If A is a real matrix, which one it is? Is real. A is a real matrix, then the eigenvalues may be complex. Eigenvalues, you have to write complex. May be complex. If it is a complex eigenvalue, one eigenvalue is a complex, next eigenvalue, one value is a complex, right, is a complex. If one eigenvalue is a complex, then next eigenvalue is a complex conjugate. Complex conjugate of that value. Complex conjugate of that value. So maybe next one is a real number or any one you have to take. So whether it may be 2 cross 2 matrix, you may get the 2 eigenvalues. Whether you have to take the 3 cross 3 matrix, 3 eigenvalues you have to get it. From that you have to see. First one eigenvalue 2i. That complex conjugate of that value is equal to minus 2i. This one is correct. Which one you have to take? All real eigenvalue also exist, because if it is real, that complex conjugate of this one also same one. This one also correct. Now you have to see e to the power of I theta, e to the power of I theta, the complex conjugate of e to the power of I theta, e to the power of minus I theta. So this one also correct. Here one eigenvalue, that complex conjugate, if it is I is a complex number, that complex conjugate is equal to minus I. Minus I is not there here. That's why which is wrong? Option D is wrong. So which option is correct according to which of the following cannot be the eigenvalues of a real 3 cross 3 matrix? If it is a 3 cross 3 matrix, what we have to take? If it is one complex number is there, that next eigenvalue, the complex conjugate of that number is there. All the three options, complex conjugate values are existing except D option. The D option is 1I0 is there. If it is I is there, that complex conjugate of I is equal to minus I must be there. It is not present here. So that's why this D option is wrong. Clear? That is the thing. This one came from linear algebra, that is matrix. Next you have to take the solutions of your differential equation d square y by dx square is equal d square y by dx square minus y is equal to 0. Subjected to the boundary conditions, y of 0 is equal to 1, y of 0 is equal to 1, y of infinity is equal to 0. What is the value you have to see? Very, very important question. Questions you may get like this. Maybe you have to take a solutions of the differential equation. Direct they won't ask in CSIR examination or GATE examination. They may ask along with the boundary conditions also. You must read the boundary condition. First you have to solve the differential equation. What is the differential equation? Once you have to see the differential equation, d square y by dx square, d square y by dx square minus y is equal to 0. If you have to take d by dx is equal to d, d by dx is equal to d, then what we have to write, Nana? D square into y minus y is equal to 0. D square minus 1 is into y is equal to 0. This one you have to take f of d into y is equal to 0. Then you have to write f of d is equal to 0. What is f of d, Nana? D square minus 1 is equal to 0. D square is equal to 1. D is equal to plus or minus 1. If roots are, what is this? Roots are real. If roots are real, the solution y of t or y of x, whatever it may be, you have to take. So y of t is equal to, which one we have to write, Nana? C1 e to the power of t plus C2 e to the power of minus t we have to write. C1 e to the power of t, C2 e to the power of minus t. This is the solution. But we know the boundary conditions. That boundary conditions now we have to apply. How we have to apply the boundary conditions? You have to see here. First, we are getting the solution. Y of t is equal to C1 e to the power of t plus C2 e to the power of minus t. Correct? C1 e to the power of t, T2 e to the power. First boundary condition I am taking. What is the boundary condition? First boundary condition, y of 0 is equal to 1. Y of 0 is equal to 1 means instead of t, you have to substitute 0. Now I am substituting. Y of 0 is equal to C1 e to the power of 0 plus C2 e to the power of minus 0. So y of 0 is equal to how much? 1 is equal to C1 e to the power of 0 is equal to 1. C2 e to the power of 0 is equal to 1. This is C1 plus C2 is equal to 0. Next, one more boundary conditions you have to apply. One more boundary condition. What is that boundary condition, Anna? Second boundary condition, y of infinite is equal to 0. Correct? Once you have to check it in the question. Y of 0 is equal to 1. y of infinite is equal to 0. Now I have to take y of infinite is equal to 0, that is the second boundary condition. Therefore, y of infinite is equal to c1 e to the power of infinite plus c2 e to the power of minus infinite, right? Y of infinite is equal to how much we have to write? This is 0. 0 is equal to c1 e to the power of infinite plus c2 e to the power of infinite is equal to 1 by e to the power of infinite. Something by infinite is equal to 0. This entire thing it will become as a 0. So therefore 0 is equal to c1 into e to the power of infinite. So c1 is equal to 0 by e to the power of infinite is equal to c1. Therefore c1 is equal to 0. So if it is c1 is equal to 0, from this what we have to write, Nana? From this what we have to write, once you have to see 1 is equal to 0 plus c2. So therefore c2 is equal to 1. If it is c1 is equal to 0, c2 is equal to 1. Then you have to substitute the c1, c2 values here. Therefore y of t is equal to, c1 is equal to 0, 0 into e to the power of t, c2 is equal to 1, 1 into e to the power of minus t. Therefore y of t is equal to e to the power of minus t. E to the power of minus t we have to write in terms of trigonometrical forms. How we have to write? Cos, we have to write this cos ht minus sin ht. So therefore which option is correct? Y of t is equal to cos ht minus sin ht is correct, right? That option is there or not, once you have to see. Cos ht minus sin ht, option D is correct. Which option is correct? Cos ht minus sin ht is there, that option is correct. So it is very, very important. Like this you may get in the question. From which area this is? Differential equations question. You may get the questions from special functions. You may get the questions from Green's theory. You may get the questions from partial differential equations. You may get the questions from secondary differential equations, Euler equation. Like that, any question you may get in competitive examination, whether it may be CSIR or GATE. Both area also this very, very important. So please concentrate on this area, right? Don't forget, please subscribe my channel and share to your friends also. Now you have to see next area. Now how many areas we completed? So we completed till now, this is the differential equation, that is a fourth area. Till now we completed only 4 parts. Now we have to see the fifth area. What is the fifth area? Once you have to see the Laplace transform of 6t cube 3 sin 4t. Already this is a problem oriented question. When they got this question, CSIR 2015 they got, maybe June or December, June I think. Now you have to see Laplace transform of 6t cube plus 3 sin 4t. I will give the formulas to find this. Now you have to take the formula. Formula number 1. Laplace transform of t to the power of n is equal to n factorial is divided by s to the power of n plus 1. S to the power of n plus 1. This is the first formula to apply this one. Next, second one, which one you have to write, Nana? Laplace transform of sin at is equal to a by s square plus a square. This is the Laplace transform of sin at. Now we have to apply. 6, it is a number, that's why you have to take outside. Laplace transform of t cube plus 3 into Laplace transform of sin 4t. 3 into Laplace transform of sin 4t. Now you substituted 6 into Laplace transform of t to the power of n factorial, 3 factorial divided by Laplace transform of s to the power of 3 plus 1. 3 into a which is equal to 4, a is equal to 4 is divided by s square plus 16 we have to write. So 6 into 3 factorial means 3 into 2 into 1 is divided by s to the power of 4 plus 4 3 is 12 is divided by s square plus 16. Right. So now 6 into 6 is equal to 36. 36 divided by s to the power of 4 plus 12 divided by s square plus 16. This is your answer. Now you have to check the option. 36 by s to the power of 4 plus 12 by s square plus 16 plus 12 by s square plus 16. 12 by s square plus 16. Two options correct is there, no? Right, no problem. So option A is correct. Now this is s cube is there. Option A is correct. 36 by s to the power of 4, 12 by s square plus 16. Here 36 by s to the power of 4 is minus is there, wrong. Here also minus is there, wrong. Right? 18 wrong. Here s cube wrong. So this part is correct, but this part is wrong. Like this we have to do. Sometimes they may ask the Fourier series. Sometimes they ask the Fourier transform. Like that also they will ask. I choose the Laplace transform question. Question may come sometime Fourier transform. Like that questions also came. Right? So this is a fifth part. You segregated like that, you have to solve the paper. Now, this is a complex analysis question. It's very important topic. Complex analysis is in CSIR or GATE, you get more number of questions, maybe 13 marks, 13.5 marks you may get in CSIR examination, 3 or 4 marks weightage you may get in GATE examination. In other competitive examination also, these complex numbers are very important. You have to concentrate. Now you have to see here. The absolute value of integral value they are asking 5z cube plus 3z square. This is a numerical answer type question. Z square minus 4 into dz. Which one it is, Nana? It is a numerical answer type question because options are not given. We have to write we have to solve and we have to kept that value. In the complex plane. What is a complex plane? This complex plane is equal to modulus of z minus 1.5 is equal to 1. How we have to compare this value? This value we have to compare modulus of z minus a is equal to r square value how to compare. Modulus of z minus a is equal to r square. From like that you have to compare. So from this value 1.5. So how we have to follow that a value, how we have to calculate? By using this poles. How we have to calculate the poles? Once you have to see integral 5z cube plus 3z square is divided by this one we have to write z plus 2 into z minus 2 into dz. This z plus 2 into z minus 2, this is a singular pole. In the singular pole, maybe you have to take this one. Z is equal to minus 2, z is equal to plus 2. So these are the poles, right? Poles. Which pole? These two poles also singular poles. But whenever the integration can exist, suppose if you have to take here, this is a complex plane. From this complex plane, maybe x-axis you have to take, y-axis you have to take here. How much radius is there? That radius is 1. How much radius is there, Nana? That radius is 1. Suppose if you have to take here, which one first you have to take? The first root you have to take. First pole you have to take. That's z is equal to minus 2 you have to take. minus 2 minus 1.5. Minus 2 minus 1.5 entanana? Minus 3.5. Modulus of minus 3.5 is equal to 3.5, which is greater than 1. Where it is exist? Maybe this is 1, maybe this is 2, maybe this is 3, next 3.5. This is a outside the contour, greater than 1. It is outside the contour. Outside the contour. If it is outside the contour, what will happen? There is no integration for this value. For this value, there is no integration. Next one we have to take. What is the next one? Z is equal to plus 2. If it is Z is equal to plus 2, once again you have to check. 2 minus 1.5. Modulus of 2 minus 1.5 is equal to how much? 0.5. 0.5 is less than 1. So that's why where it is sitting? Inside the contour. Z is equal to 2 is inside the contour. Inside the contour. So that's why, so there is integration is exist. How we have to calculate the integration? First, if it is a complex integration is there, first you have to find the radius. What is the radius? From this formula you have to calculate the radius. R square is equal to 1 means R is equal to 1. Now you have to draw the complex plane. After drawing the complex plane, then you have to find the simple pole. So you have to find the poles. 2 poles you are getting. According to the question you are getting the 2 poles. When Z is equal to minus 2, Z is equal to plus 2. If it is Z is equal to minus 2, what will happen? Outside the contour is there. If it is outside the contour, that integration is equal to 0. But we have to get the answer. How we have to get? One more pole is there. That one more pole purpose, that integration is existing. What is that integration? We will see now. What is the integration? Now, at Z is equal to 2. At Z is equal to 2, we have to see. This is the inside the contour. That's why you have to calculate the residue. The residue of Z is equal to 2. The residue of Z is equal to 2 for a simple pole. Which one we have to take, Nana? For a simple pole, how we have to write? Limit Z tends to 2 f of Z into Z minus 2. Right, f of Z is equal to which one we have to write? Limit Z tends to 2. Limit Z tends to 2. So which one it is? F of Z is equal to 5Z cube plus 3Z square. 5Z cube plus 3Z square is divided by Z minus 2 into Z plus 2. Right, into Z minus 2. Z minus 2, Z minus 2 get cancelled. Now you substitute the 2 value here. 5 into 2 cube plus 3 into 2 square is divided by 2 plus 2. So that is equal to how much you have to get? 5 into 8 plus 3 into 4 is divided by 4. 5 into 8, so 40 plus 12 is divided by 4. This is 52 is divided by 4. 52 is divided by 4. How much value you are getting, Nana? So 4 1 ja, 4 3 ja, 13. You are getting the value 13. Residue of f of z at z is equal to residue of f of z at z is equal to 2. How much value you are getting? 13 value you are getting. Correct? But what we have to calculate? We are calculating the integration value. How we have to calculate the integration? Integration of integral 5z cube plus 3z square is divided by z minus 2 into z plus 2 dz is equal to, there is a formula is there. That formula is 2 phi I into residue of f of z, residue of f of z. Already residue of f of z we found. Now you substitute 2 phi I into 13. So 2 into 3.14 into 13. So this value you enter there. How much value you are getting, Nana? So this value, how much you have to get? 81 point, this value 81.64 I you are getting the value. So that is the integration value. So that numerical value how to enter in the 81.64. This value how to enter in your computer. If you have to solve the entire expression, you may get the answer. That answer you have to enter here, right? Like these questions are, this is a numerical answer type question. Numerical answer type question. NAQ. For this question, no negative mark is there. No negative. No negative for numerical answer type question. This question GATE 2018 February. This question is for GATE 2018 February. This is the 6th one. Now, according to our segregation, we have to see. We have to see that probability distribution. 3 probability distributions are there. One is the Poisson distribution, normal distribution, and so rest of the distribution is binomial distribution. Normal distribution, Poisson distribution, binomial distribution. Within the 3 distribution, not only 3 distribution, some elementary ideas of the probability theory also question you may get. How questions are there once you have to see. In CSIR 2011, one question is there. Well, that simple question I make it. An unbiased dice is thrown 3 times successfully. 3 times we are unbiased dice is there. The dice we have to thrown 3 times successfully. The probability that the number of dots, the uppermost surface add up to the 16. You have to add the sum is equal to 16 you may get. How you have to get the 16? 3 times we have to give. An unbiased dice is thrown 3 times. In 3 times, how many dots? The uppermost dot surface add up to the 16. Up to some 16 we have to get. What is the probability for that? They are asking. What is the probability? The probability is equal to the number of success is divided by the total number of trials. The total number of trials is equal to total number of trials. Total trials, right? This is the probability expression. How we have to get? Every dice has 6 surfaces are there. Out of 6 surfaces, each and every time, 3 times we are giving. So total 16 we want to get. How we have to get? 2 ways are there. First 6, 5, 5. If you have to take the 6, 5, 5, 5, how many times it should be rotated? 3 ways are there. Right? Next, one more time also is there. How you have to get it? 16, 6, 6, 4. So this is also, you have to rotate under 6, 6, 4. You may get 3 ways. This one also, you have to get the 3 ways. Right? Therefore, the total number of ways, how we have to get? So total number of ways is equal to 3 plus 3. How many ways, Nana? 6 ways. Total number of ways is equal to 6 ways. N is equal to 6. Therefore, the total number of probability is equal to 6 is divided by how many trials we want to get? 3 times we are giving. Each and every dice. So 6 faces is there. 6 into 6 into 6. First dice trial, second dice trial, third time trial. So 6 get cancel. 1 by 36 is the answer. So what is your option? Option B is correct. Which option is correct? Option B is correct. Like this, we have to do in your examination. This is the probability question. Very simple to find the probability. Like that you have to do. 2011 we got the question. Now 8th part, maybe a couple of minutes I have to wind up this one. Right? Now you have to see the value of integral. The value of integral is a very important. It's a numerical method question. A 0 to 8, 1 by x square plus 5 into dx. So this value of integral evaluated using the Simpson 1 by 3 rule. So h is equal to 1 by 2 is. There they are giving the h value. H is equal to 2 is they are giving. So that answer we want to get. Simpson's 1/3 rule. First we have to take here f of x is equal to 1 by x square plus 5. Now you have to apply the 0. So f of 0 is equal to something by 0 is equal 1 by x square plus 2 is there. You have to take the values. What the value you have to take? So that value you have to see. Which value you have to take, Nana? 1 by x square plus 5. If you have to substitute f of 0. F of 0 means y0. Y0 is equal to 1 by 0 plus 5 is equal to 1 by 5. Next y1, f of 1. So x is equal to 2. So y2 you have to take, that is f of 2. The next one is 2 because h is equal to 2 is there. 2 you have to increase. Y2 is equal to which one we have to get? 1 by 4 plus 5 is equal to 1 by 9 you have to get. Next y3 f of 4 you have to take, that is 1 by 4 ja 16 plus 5 is equal to 1 by 21. Therefore y4 is equal to f of 6 is equal to which one we have to write? 1 by 36 plus 5 is equal to 1 by 41 you have to get it. Next up to 8. So y 5 is equal to f of 8 is equal to 1 by 25 plus 5. So 25 8 64 plus 5. 64 plus 5 is equal to 69. 1 by 69 you have to get. Now we got the values. This is a y0 value. This one is a y1. This one is y2. This one is y3. This one is y4. Right? Now we have to write the formula. Simpson's 1 by 3rd rule we have to use. Simpson's 1 by 3rd rule. What is the Simpson's 1 by 3rd rule? The integral I is equal to h by 3 into y0 plus y4. y0 plus yn means y4 you have to write. y0 plus y4. Right? Which one we have to write, Nana? y0 plus y4 or yn. So you have to take up to the n value. If you want to take the last value, that is a yn you have to write. Plus which one we have to take here? So we have to take 4 into y2 plus y4. y2 plus y4. This is the even value. Plus 2 into y3. 2 into y3. Like that you have to substitute. Right? So here, so y4 is there. So we have to substitute that value. This is the Simpson's 1/3 rule. Right? Simpson's 1/3 rule. From this rule, you have to apply I is equal to, h is equal to 2. 2 is divided by 3. y0 is equal to 1 by 5 plus yn is equal to 1 by 69 right, plus 4 into y2 is equal to, we have to write y2 is equal to 1 by 21, y2 is equal to 1 by 21, right, this is y2 value, sorry, y1, y2, y3, y4, right. So y2 is equal to 1 by 21. Next y4 already yn lo ochindi, so we need not to use, plus 2 into y3 is equal to 1 by 41. 1 by 41, y1 plus y1, we have to take, which one we have to take, y1 plus y2. This y1 also you have to take here, y1 plus y2 plus 1 by 9 plus 1 by 9. You have to calculate. So, you have to do this one. y1 plus y2 also you have to take, y3 plus y6 it will come. Up to here only there. Now, you simplify. If you simplify, you are getting the option. That option may be approximately 0.565. You able to get option A you are getting. Like this you, maybe Runge Kutta second order, Runge Kutta fourth order, Simpson 3 by 8 trapezoidal rule, like that any question you may get. Clear? So, this is the Simpson 1 by 3rd question, CSIR 2015 they are asking. This is a 5 marks question. Please concentrate. This is 5 marks. How many marks you have to get if you have to do this formula? You know the formula, you have to do this question, you may get the 5 marks. Clear? That is the thing. Next, 9th one you have to see. Consider an anti-symmetric tensor. This is the tensor one. A anti-symmetric tensor is, what is the tensor? Suppose if you have to take a vector, one dimension and one direction is there. One dimension, one direction, magnitude and direction is there. Then we call it as a vector. If you have to take a tensor, magnitude is there, but directions are many. Suppose you rotate the top on the floor, right? It will be rotated. So, directions are many. Which direction it will be rotated? We don't know. Directions are many, but magnitude is existing. Such type of vector we call it as a tensor. It is the advanced part of the vector, we call it as a tensor. Right? What they are asking you how to see? Consider an anti-symmetric tensor. Tensors also two types, symmetric and anti-symmetric. Indices I and j running from 1 to 5. 1 to 5 means total number of running things you have to take, that is the number 5. Right? The number of independent components. The number of independent components for anti-symmetric tensor. Anti-symmetric tensor. Number of independent components for anti-symmetric tensor is equal to n into n minus 1 by 2. There is a formula. Just n they gave. Just you have to substitute the n value here. You may get the answer. N is equal to 5 into 5 minus 1 is divided by 2. 5 into 4 is divided by 2 is equal to 20 by 2 is equal to 10. 10 is the option. 10 is correct. Like this you have to get. Not only this, covariant and contravariant, the Chernobyl symbols, any question you may get in your competitive examination. I took this one, right? Now the last one, this is the 10th part. According to my segregation I am doing, right? Now you have to see, which of the following matrices is an element of the special unitary group 2. For a special unitary group 2, there is a formula is there. What is the rule? Rule for a special unitary group 2. If it is vector alpha minus beta, so conjugate alpha minus beta conjugate. Suppose you have to take beta alpha conjugate. Which one you have to take? Alpha conjugate. So, if it is vector like this is there, if alpha beta conjugate, there how it is exists, modulus of alpha square beta square is equal to 1. If alpha and beta belongs to the complex number, alpha and beta belongs to a complex number. Which number it is? Alpha and beta belongs to the complex number. Suppose you have to see, here 1 bar is equal to 1. Here 1 is not negative. This is not correct. Here 1 plus I is there. 1 minus I. This one is correct. 1 by root 3 is there. Minus 1 by root 3. According to this rule, so which one is fitting? Option B is fitting. Now you have to see here, 2 plus I. 1 plus I. This is not correct. 1 by 2. This is not correct. So maybe complicated number, but here minus is not there. This is not. So suppose if you have to take here, so you check it. Modulus of 1 plus I by root 3 whole square plus 1 plus I root 3 whole square plus modulus of 1 by root 3 whole square is equal to, whether it may be 1 or not, you have to check it. So you will get the 1 only. 1 by root 3, 1 by root 3. So 1 plus I root 3, 1 modulus of 1 plus I whole square is equal to 1 plus I into 1 minus I. You have to get it. So that one, so you may get 1 only, you have to get it. 1 by root 3, 1 by root 3 get cancelled. You have to get it the 1 only. Value is 1 only you are getting. So that's why option B is correct. When they are giving, this is the CSIR 2011 they are giving. Clear? So like these questions you may get. I segregated the 10 parts. Among the 10 parts, I gave one question solution. How the questions are there. These are all questions from CSIR or GATE examination only I downloaded and I explained to you. Now you have to listen. CSIR and GATE batch. We will start. Quantum Online Academy will start purely online mode only. From 7th January 2024 onwards. 7th January 2024 onwards. Live plus recording classes. This is the live and recording. 6 a.m. to morning 6 a.m. to 8 a.m. every day. Morning 6 a.m. to 8 a.m. except Sunday. Except Sunday, morning 6 a.m. to 8 a.m. daily 2 hours for completion of the 9 papers. You have 9 papers are there. One is mathematical methods of physics. The second one is the classical mechanics. The third one is a electromagnetic theory. The fourth one is the quantum mechanics. The fifth one is a thermodynamics and statistical mechanics. The sixth one is the electronics. The seventh one is condensed matter physics. The eighth one is a atomic molecular physics. The ninth one is nuclear and particle physics. Total 9 papers are there. Up to completion of the 9 papers, not 6 months or 7 months course. Up to completion of the 9 papers. Maybe it can take the 8 to 9 months. From January to, I am putting the December target. Up to 9 months we have to give the course. 1 year validity is there. You have to go to the Play Store, right? So Play Store, not App Store is not there now. Go to the Play Store. You download my app, Quantum Online Academy. This is the symbol of the app, right? This is a symbol of app, Quantum Online Academy. So for this symbol you have to download from Play Store and then you may go for purchasing the course. That course is CSIR and GATE batch. CSIR and GATE batch. My numbers are 990. My cell phone numbers you have to take 990-843-7460. This is my regular number, right? This one is the institute number 630-326-3368. This is my institute number 630-326-3368. This is my institute number. This one is my regular number. You have any doubt, you call me. How you have to approach to join in the online course. It's purely online, right? CSIR and GATE, purely online. My primary motto is to expertise the physics teachers or physics teachers. Already so many people know me because I told in the last jail coaching time, all papers I told, you ask who are taking the winners online. So you ask them, they will tell my name, right? Thank you. This is your Dr. Nagaraju Pendam. So please subscribe my channel and share to your friends. Not only Telugu people, throughout India purpose I am starting. No Telugu language, only English language only. Thank you. Thank you for listening your